In this video, we will be recapping the different forms of quadratic relations. So let's start off with a visual. So I'm giving you the equation y equals x squared plus x minus 12. And first question, what form is this equation in? Because there are no brackets and it's fully expanded, this is in standard form. What is the coefficient of x squared? Well, there's nothing in front of it, so that means it would just be a positive 1. And I'm writing the positive just because of the follow-up question, which is, does the parabola open up or down? Because that 1 is positive, it opens up, but we can also see that it opens up from the visual on the side. What is the constant term in the equation of this graph? Well, the constant is negative 12. What is the y-intercept? Well, visually, if we look at the y-axis, we see that the parabola passes through at negative 12. So they match. So as a reminder, the constant in standard form is the same as the y-intercept. Next, we're going to factor the trinomial. And it is a simple trinomial because it starts as x squared. So my product, or the multiplication, is negative 12, and the sum, or the addition, well, there's nothing in front of x, so it's just a positive 1. So if it multiplies to a negative number, we should have a positive and a negative number. When I think of 12, I think of 4 and 3 right away. And if I make the 3 negative, 4 plus negative 3 is 1, so that's perfect. So the factored form, I set up my brackets, they each start with an x. So x plus 4, and then x minus 3. What are the zeros? Well, looking at the graph, one of them is at negative 4, and the other one is on the other side at positive 3. And if we notice, it's the same numbers from the brackets, but the opposite sign. So, what does the standard form of a quadratic tell you? The direction of opening is based on a, so the value in front of x squared. The y-intercept is always the constant, which is c, if we look at the generic form. For factored form, the direction of opening is based on, again, that a value, so the value in front of everything. And the zeros are the numbers inside the brackets, so if we look at the generic example, it'd be the r and the s, just remembering the opposite signs. Now the letters don't mean anything, it's just the generic form, but there it is. All right, let's try some examples. So the first set of examples I have in factored form, and we're going to find the zeros, the y-intercept, the direction of opening, and if there's a max or a min. So if it's in factored form, the first thing that we can get are the zeros, and regardless of the form, we can always get the direction of opening. So if we look at this first example, there's nothing in front of the bracket, so it's just a positive 1. So that means this opens up. Now, because it opens up, we can also tell if there's a max or a min. We don't know the actual value, but we can figure out what we have. So it's opening up, which means this vertex here is a minimum. For the zeros, let's look at the numbers inside the brackets. We have negative 7, so one of our zeros is positive 7. And we have negative 1, so one of our zeros is positive 1. So remember to switch those signs. Now for the y-intercept, we do need this to get into standard form, which means we have to expand and do some FOIL. So because we have two binomials, or two brackets with two terms in each, we're going to do our FOIL. So I'm going to take the x and I'm going to multiply it into that second bracket. So x times x is x squared, and then x times the negative 1 is negative 1x. Then I'm going to take negative 7 and multiply it in. So negative 7 times x and -7 times -1. Be very careful with your signs. If you mess those up, then it takes away from the right answer. And then we'll just collect our like terms. So -1 minus 7, that's -8x's, and the plus 7 stays. And here's the y-intercept. So 0, 7. All right, let's try the next one. So I just want you to pause the video here and just write down if it opens up or down, max or min, and what the zeros are. Then come back to check your work. So because we do have a +2, this is going to open up, which once again, if it opens up, we have a minimum. I like to draw the visual just to see the max or min a little better instead of memorizing. For the zeros, I have a +5 in one of the brackets, so hopefully you wrote -5, 0, and you do have to write it as a coordinate for good communication. And then the other bracket says -3, and the opposite sign is +3. And now let's do our y-intercept. So we have to expand this. Now notice that there is a coefficient in front, and remember when we expand, we're going to keep the 2 out in front. And then we'll do our FOIL. So we're going to multiply the x in, and then we'll multiply the 5 in. So again, why don't you pause the video here and get your expanded form, and then come back to check your work. So x times x is x squared, x times -3 is -3x, and then we'll bring the 5 in fully, so 5 times x, and then 5 times 3. I'm going to collect my like terms first. So -3 plus 5 is +2x's. And then if you stopped here and you said the y-intercept was -15, well, this isn't actually fully standard form, so that's not actually correct. We do have to take this 2 and distribute it fully, and then we can write down our y-intercept. So 2 times x squared is 2x squared, 2 times 2x is 4x, 2 times -15 is -30. Here's our y-intercept. So 0, -30. All right, so we did a basic example that was just 2 simple brackets. We did a harder example where there was a coefficient in front, and now we're going to do kind of a weird example in that we don't actually see 2 brackets. You kind of just see this 2x chilling there. So first of all, it is a +2, so it opens up, and as a result, we have a minimum. Now for our zeros, I don't have a problem with this bracket. It says +5, so -5, 0 will be a 0. But then the other one, there is no bracket. It's kind of just there. If you would like, you can always write it like number 2. I'm going to write the 2 out in front, and then I'll put that x in a bracket. And because there's nothing beside it, if I wanted to, I could just write x + 0 or x - 0. It doesn't make a difference. These mean the same thing. Now, no one writes it like that because, well, writing +0 is a little silly, but this way you can see that the other 0 is 0. Or, you know, because there's nothing there, remember, if nothing's there where you need it to be, it's automatically 0. All right. In this form, maybe the zeros or the x-intercepts look a little funky, but the y-intercept is actually a lot easier because we don't have to do any FOIL. We can just rely on our grade 9 distribution knowledge. So we're just going to do 2x times x, which is 2x squared, and 2x times 5, which is 10x. You'll notice the constant is missing, so we can write +0, so that our y-intercept is 0, 0. So notice we had something missing in a bracket, and we had the constant missing, so in both scenarios, we have an x and a y-intercept at the origin of 0. All right, so all of these examples were from factored form. So you can quickly get the zeros, but you had to work a little bit for the y-intercept. Let's go in the other direction. I have standard form here, so that means we can get the y-intercept quickly, but we're gonna have to work for our zeros. Okay, so we have y equals x squared plus 2x minus 35. So first of all, there's nothing in front of x squared except the positive 1. So this opens up. So once again, because it opens up, we have a minimum for that vertex. The y-intercept, well, the constant is negative 35. So the y-intercept is 0, negative 35. Now for the zeros, we have to factor this. And we have 3 different factoring methods, but because I see that it's a trinomial and it starts with x squared, it is going to be the simple trinomial. So I need a product of the constant, which is negative 35, and I need the sum to be the coefficient of x, which is 2. So I know I need a positive and a negative number. 7 times 5 gives me 35, and if I make that 5 negative, that's perfect. So the factored form, x plus the 7, x minus the 5. So when I'm factoring, I write the numbers as is. But when I take down my zeros, I'm going to take the opposite sign. So instead of positive 7, it's going to be negative 7. Instead of negative 5, it's going to be positive 5. And there it is. So starting with standard form, the extra work you have to do is factoring. If you start with factored form, you have to do some FOIL or expanding. All right, number 5. I want you to write down the direction of opening, max or min, and the y-intercept, then come back to check your work. So this once again opens up because the 2 is positive, which means we have a minimum. I know I don't have to draw the sketch each time because at this point we've seen up so much, but I like to do it. Your y-intercept is the constant, which is the 24, so 0, 24. And now we have to factor. Now this is not simple because there's a 2 in front. And if there's a 2 in front, and if it's common to all 3 numbers, we can do a GCF of 2. So that means I'm going to divide all of these by 2. Y equals 2, open up your bracket. 2 divided by 2 is 1, so now I have 1x squared, which is going to make this simple. Negative 14 divided by 2 is negative 7x, and 24 divided by 2 is 12. So now that I have a simple trinomial, I know I'm not done. I can't get my zeros. This isn't fully factored. I don't see those nice 2 brackets. So my product is 12, and my sum is negative 7. So if my product is 12, that means both numbers are positive or both numbers are negative. Because they have to add up to something negative, they both have to be negative. And when I think of 12, negative 4 and negative 3 come to mind, and those actually work. Maybe you thought of negative 6 and negative 2, but if you add those up, you get negative 8, so that doesn't work out. So our factored form, don't forget about the 2, and then x minus 4 and x minus 3. So for our zeros, we're just going to take the opposite sign. So instead of negative 4, we're going to have positive 4. Instead of negative 3, we're going to have positive 3. And there we have it. All right. Number 6, y equals negative 4x squared plus 16. Pause the video. Tell me up or down, max or min, and what the y-intercept, then come back to check your work. So this is going to open down for once because we do have a negative 4 attached to the x squared. And when it opens down, the vertex up here is now a maximum. The y-intercept, nothing fancy. I do have 2 terms here, so you have to be careful. 16 is a constant. It's not attached to a variable, so it's definitely our y-intercept. If, however, let's say there had been an x attached here, that would not be our y-intercept. Our y-intercept would be 0, but that's not the case. All right, time to factor. So it's not a trinomial. I see that right away, so I know I'm not going to do the product and sum shortcut. I do see that my first term is negative, and I know the first step, if there's ever a negative at the start, is to take out a GCF, a greatest common factor. So it's going to be negative, but the 4 and the 16 are both divisible by 4. So I'm actually going to take out a little bit more than that. And we're going to have to be very careful with our signs. So when I take out the negative 4 divided by negative 4 is positive 1. So I'm just going to write x squared. If you want to write 1x squared, that's fine as well. And then 16 divided by -4 is -4. And at this point, you will see two terms with subtraction, and the 4 and the 1 and the x squared are both square rootable. So we now have a difference of squares. So remember, with your difference of squares, we're going to square root both of those terms. So the square root of x squared is just x. The square root of 4 is 2. So when we set up our brackets, don't forget about the GCF, but then we're just going to have each bracket starting with x, each bracket ending with 2. One will be positive, one will be negative. Super quick, if you can identify it. All right, and finally, our zeros. The first bracket had a positive 2, so the 0 is -2. The second bracket had a -2, so the 0 is +2. And again, notice for the y-intercept and the zeros, I'm always writing them as coordinates because that is proper communication. And that's it for your forms. We know how to convert between them, between factored and standard, by doing either distribution or one of the factoring methods. And we should be able to get those properties once we have the appropriate form.